looking at shapes which are translated or rotated. These are called transformations. Now, a transformation moves one object from one position, or maps an object from an original position to its final destination or its image position. And so we're going to look at an example of what I call cmath concept 766. Now, if we have a shape, I'm going to just freehand draw a shape, for example, and let's look at an L. An L is a good shape to use. Now, if we were to rotate this clockwise a quarter of a turn, so I'll just put rotate clockwise. We could go anti-clockwise, but this question says rotate it clockwise, and clockwise is the direction of the clock, tick-tock, tick-tock, so which direction does the hand move around the clock? So then we're talking this direction here, and 1/4 of a turn would take us just this far. Okay, so we're going to rotate clockwise 1/4 of a turn. Now, 1/4 of a turn is like 90 degrees, really. So if we were to rotate it just 90 degrees, it kind of like will just fall over. So what was vertical, this line here, for example, will end up being horizontal. So we'll make a purple shape. So if I push it over, then the L will end up being looking like this. It's fallen over. It's rotated 1/4 of a turn. Now let's look at a different shape, and let's do a different direction. So let's take a we'll take like a skinny triangle. It's like an L in a way. We'll make like a 90-degree triangle here. Now, if we were to rotate this, and this time let's rotate it anti-clockwise. So you've got to know this goes against the clock. So anti-clockwise is not the direction that the clock turns, but the other direction. So I will just put this direction. That's against the clock direction. So it's anti-clockwise. And let's do this time 3/4 of a turn. That's unusual. That's more than 1/4. It's more than 2/4. So 3/4 is like 1/4 is 90 degrees. So 3/4 will be like 270 degrees. So if it goes this way, if it falls over, that's 90 degrees. So if it falls over, it's going to sort of look like this. Now if it rotates again 1/4 of a turn, then it will look like this. That's 1/4, 2/4, 3/4. The 3rd quarter is if it rotates again, this side will end up being along here, and this side we'll just put here. This side will end up being down here, and so we've got, here it is, the blue triangle is the answer. We'll put here, the blue triangle is the answer. It would be the same as clockwise, 1/4 of a turn. However, this question wanted 3/4 anti-clockwise. Now, sometimes they have also in transformations, they have this reflection line, and it's called a line of symmetry. So what I'd like to do is use this time just to talk about line of symmetry. It's part of concept number 766. So if we take any shape and make it a an x. Now if this was a perfect x, we would have, well, it's not really a very good x at all, is it? That's all right, that's life, it's freehand. The world of technology. Now, if we want a line of symmetry, we want to know where can we fold it so it folds in half. So here's one line of symmetry. If we fold it in half that way, we could fold it in half this way, and that's it. You can't fold it in half anywhere else. So there are, in fact, two lines of symmetry, and I've drawn those in purple. So you just have to find where it will fold, and so each side of that fold, each side of the line of symmetry, it's identical on both sides. Kind of like some people say your face is supposed to be symmetrical, but it's not really. Our left side of the face is slightly different than the right side of the face. Sometimes we have a small blemish or some little spot on one side of the face and it's not on the other. Okay, so this is transformation skill number 766. I hope this has helped. So until I talk to you again, stay happy.